Okay, welcome back. Haven't scared you off just yet. So, looking at this last one down here, again, first you gotta ask yourself, are these triangles similar? So, the fact that these two lines are parallel, this side with length 12, side with length 8, it tells you all you need to know for these to be similar triangles, because that will tell you that this angle and this angle are the same, and that this angle and this angle are the same. Alternatively, you can see you have a little X pattern here, and that's one called opposite angle theorem, so these two are also the same. So these triangles are clearly similar. And just like before, we're looking for, we're looking for a scale factor. So we know that 12 and 8 go together. So your scale factor there is 12 over 8, which reduces down, just like before, 3 over 2. And you just got to watch what your corresponding sides are. The side that's x here does not go with 14, it goes with the 16 that's right here. So these two go together. So 16 over x will be equal to my scale factor, which in this case is 3 over 2. Multiplying both sides of the equation by x will get me 16 times 3x over 2. And then from here, it's just, again, a little bit more algebra. So I'm going to multiply both sides of the equation by 2. That will give me 32 on one side. And once these cancel, I'm going to get 3x. So that will leave me with an x value of 32 over 3. Okay. So a couple more to go before we call it a day. I'm telling you these two triangles are similar here. That triangle ABC is similar to triangle BDE. So just want to find some missing measurements here. So looking at this statement right here, if I'm looking for DB, which is this length right here, this should correspond with side BA if I'm looking at my original similarity statement up here. Okay, so again that means DB is going to go with BA, which is length 12 right here. So that's helpful and all, knowing that these two sides are corresponding. However, it's useless unless we can find a scale factor. So a pair of corresponding sides we do know is that DE, which is this one right here, is going to correspond with BC. Okay, so we can get our scale factor of 8 over 6, which reduces down to 4 over 3. Okay, with that in mind, we can then solve for dB. So I'm just going to call this one x over here. So that would mean that x over 12 is 4 over 3. Multiply both sides of the equation by 12, and you're going to wind up with x is 12 times 4 is 48, divided by 3 is 16. So that side length becomes 16. Okay, so that does it for part 1. Part 2 asks for angle DBE. So looking at angle DBE, that's referring to this angle right here, angle B. Looking up here in our original statement, angle B should correspond to angle A in the first triangle, which is down here at 32 degrees. So right away we can get that one to be 32 degrees. And last but not least, angle C, which is this one right here. Two ways of going about this one. We're inside a triangle here where all these three angles have to add to 180 degrees. So you can go 180 degrees, minus 63, minus 32 to get your answer. Or you could look at the fact that this angle C has to correspond with the angle E over here. Either way, you get an answer of 85 degrees. Okay, one final example. And we're going to look at a word problem here. I want you to try and sketch this out and solve it on your own first. So pause, and when you're ready to go, push play. Okay, so just sketch this out. We're going to have a gigantic tower here. So why not use this little lighthouse here? And that's going to cast a shadow that is 750 meters long. So look out here, cast a shadow. That's going to be a right angle there. Excuse my drawing, but that is going to be a right angle there. And the shadow is going to be 750 meters long, and we have absolutely no idea what the height is. Okay, so at the exact same time, we're going to have a meter stick. So a less exciting thing right there. So this is obviously 1 meter tall. and the shadow is going to be 1.4 meters long. And we just want to know what the height of the tower is. So it looks like it's setting up nicely for similar triangles. Again, we got to ask ourselves, are these similar? Well, they both have a 90-degree angle right here. And the other key thing this problem is telling us these are going to be similar is that these shadows are being cast at the same time, which means the sun's position in the sky. There's our fancy little sun up there. The sun's position in the sky isn't really changing, so it's going to make the same angle to the ground with each one of these. So these are similar triangles, so we can use a scale factor proportionality statement, whatever you want to call it. So between these corresponding sides, we have 750 and 1.4. So 750 over 1.4, which is our scale factor, should be equal to h over 1. Okay, which really just simplifies down to h. So h is going to be 750 divided by 1.4. Run that through your calculator, and you get approximately to one decimal place, 535.7 meters. Okay, so that's it, that's all. Homework's over here. Good luck with it, and then from here we're going to move on to trigonometry. Okay, have a good one.